I'm really excited to be here in Toronto at DevOps Days talking about just-in-time infrastructure. So I'm going to start my talk off by going over a little bit of the journey me and my team took and how we ended up at this model of just-in-time infrastructure. Next, I'm going to spend a little time defining what do I actually mean by just-in-time infrastructure? What is this made-up term? What does it actually entail? And then I'm going to spend the core of it talking about both the benefits and considerations from adopting this model. As with everything, there are going to be trade-offs, so I want to highlight both the pros and the cons, and then specifically about the cons, talk about some of the ways you can address them in practice. And at the end, I want to go over a little bit over some examples of my team using these just-in-time infrastructure principles, and I think there are some powerful and some unique ways. And then at the end, I'll leave some time for questions as well. Yeah, so it all started off when my team was tasked to build a data science platform for the data scientists in our company. So the data scientists ranged from requiring multi-cluster, GPU-backed machines to the average data scientist who was just playing around. These data scientists both needed compliant, secure, and a lot of extra tooling as well. A lot of them were working with sensitive data. So we need to make sure and handle all these considerations. So before we started building out, we determined a couple requirements or some things we would have to solve for in order to be successful. And the one thing was the dynamic infrastructure. We wanted the data scientists to have really customizable and personable infrastructure for their unique needs. So we wanted them to be able to interact directly with the underlying infrastructure and have a lot of control. Next was a no-ops solution, or as close to no-ops as we could. We were a team of only 5 engineers, so we didn't have the bandwidth to do a lot of the integrations, to get a lot of the operations to scale out. I mean, what we like to do is build out new features and code, not deal with a lot of the operations. And then we wanted to have a shareable platform. Because of a lot of the secure data and sensitive data, we did not want to have a centralized platform where the data was coming to us. It adds a lot of responsibilities. Having to go with legal is a no-go. So we wanted to make it shareable. We wanted to have our platform be easily ingested into any account where the data scientists already are and where the data is. Now, I'm sure most of you are familiar with infrastructure as code. A lot of the other talks were kind of talking about this, which provides the ability to deploy and build your infrastructure via code or code-generated files. And while this is great, it allows you to speed you up and have a lot more control of the infrastructure, as you scale out, there are some operations and there are some things that will happen. So especially in big companies, you'll have specific infrastructure teams handling all the infrastructure separated from the application teams. While there are a lot of benefits to this can actually cause extra operations, communications, overheads. It actually can lead to some problems down the line. For example, if the infrastructure team makes a small change, it requires the applications to make some as well. If the applications don't have the bandwidth or kind of configure something poorly, one small infrastructure change can actually affect the whole ecosystem, causing the applications to go down. And it's hard to kind of recover since all the applications could be affected. And then on the other side, application teams want to move fast. They want to move quickly. They have deadlines. And then splitting up the teams requires this dependency on the infrastructure teams. You need to go through various processes, governance, in order to get things spun up, especially when there are deadlines such as a code freeze. These infrastructure teams can have really large backlogs, causing delays, and causing applications to miss deadlines, a lot of finger pointing there. So this is kind of the atmosphere where we started kind of generalizing to this just-in-time infrastructure model, which ties the infrastructure to the application codes in a more tightly way. So what is just-in-time infrastructure? So what do I mean by just-in-time infrastructure? Essentially, the core essence boils down to a model in which the entire infrastructure stack required for an application is written and built alongside the application and deployed along with the same life cycles. So this is a pretty simple principle. It actually has some profound effects. So what this entails is now you are versioning your application and your infrastructure in the same way. It's in the same repo. So a PR where maybe you're changing a security group or something that requires an application code change, it will be in the same PR, in the same location. So it's easy to understand the interactions between the application and the infrastructure. And what this entails is the application team to kind of own more of the stack. And this can depend on the use case. from maybe just some of the core application infrastructure, such as maybe your containers, your clusters. But ideally, you would want everything from the networking to the like VPC security as well. And this requires the application teams to maybe have some knowledge trainings to understand what's actually going on underneath. And while this is some extra work, I think it generally makes the developers better to have a bigger picture of what they're actually working on. And then another core tenet is you're running the same infrastructure code across your environments and across your accounts. Most companies will have dev, QA, and prod accounts, but a lot of the times they're not really exactly the same. This is because the infrastructure moves at a different pace as the applications, and things are always changing. Especially around the prod accounts, infrastructure, you generally don't want to make breaking changes, so it moves a lot slower versus your dev accounts, which can cause problems down the line since your application in dev is really not going to be running the same way as in prod. So by tying everything together, you ensure everything is going to be the same in multiple environments and multiple accounts. Oops. Yeah, now I want to talk a little bit how we started tackling some of this principle. So the main thing, we actually built our own Python-based cloud resource management framework, which has actually recently been open sourced by Capital One under the name Particle Cloud Framework. So this framework was built with this just-in-time infrastructure model in mind, but it's not a requirement if you want to follow some of these principles. So we actually used Terraform and CloudFormation templates initially, but we had some difficulties with, especially around the dynamic nature of our infrastructure. Since users were interacting directly with the infrastructure, there was no set state. We wanted it more API-driven versus CLI. And what the Particle Cloud Framework actually does is it abstracts cloud resources into their lifecycle stage, such as running, terminate, or stop, and allows users to declaratively interact with their resources without requiring any knowledge of the current state or having any store of state files you'll have to manage. Additionally, this framework is built around defining relationships between these resources in a sort of dependency graph way. So you make sure your infrastructure is created, updated, and deleted in the correct sequences. And kind of where the real power comes from is the Pythonic nature, which allows you to extend and add really custom logic into your infrastructure. And you can tailor it to your application and add some really cool and powerful things when interacting with your infrastructure. Now, that's all I kind of want to talk about there. And now I want to dive more into the kind of core benefits, what you actually get from this model. So while it was initially conceived to simplify the deployment of applications, as well as reduce the operations burden for our team, we actually noticed, oh man, maybe someone should help them. But it was there to kind of reduce some of the ops burden and also make our platform more shareable. But some of the benefits we actually came out of this that we didn't initially think of was application isolation. So by tying your application directly with your infrastructure, it reduces the need to have a lot of these shared infrastructure components. And what this means, say if one thing can affect all the applications and goes down, your entire ecosystem can be kind of down in one swoop. And also, to recover, there's a lot of points of failure where it is. By isolating your application and your infrastructure together, only one application will be taken down at a time, and it's really easy to figure out where the problem is since the code is all in one place and one team owns it, probably in the latest PR or the latest couple PRs. Another really cool benefit is cost management. So especially for big companies with big accounts, you're going to have a lot of rogue and unused resources kind of lying around. And most companies will do better safe than sorry. And if you don't know what it's for, you generally leave it, or it takes a long time to track down every single person who might have needed it. Maybe it was an old developer that was just testing something new, but also could be a key part to an application. But by tying all the infrastructure directly to the application, you know exactly where this infrastructure belongs, and if it doesn't belong to anyone, you can safely delete it. And then you can also locate potential problems much faster. Then with security, kind of on the similar vein, by reducing the number of unused and kind of these rogue infrastructure pieces, you can make sure your environment is much more secure. You're not going to have a lot of these old, outdated resources kind of lying around that are potential vulnerabilities or avenues for malicious actors. And as well as a lot of the times, if the infrastructure team takes a long time to get things done, I know my personal experience from deploying security groups, there's a whole long process. But since there's so many resources out there, and if they're loosely defined, there's a lot of ways around it. So I remember I know specifically on Amazon, you can actually attach multiple security groups. So instead of trying to go through and get something approved, I just apply as many things as I can until something works and then just deploy that. But that's not very secure, and that would make any ISO very unhappy. Another thing is drop shippable. So this means that you're shipping your application together with the required infrastructure to run it. So this way you know exactly how it's going to run. It reduces the need for having dedicated integration teams, and is especially great for POCs and those types of things where you want something to work quickly and demonstrate the viability of a solution. And then auditability is another key one. Because your infrastructure and your code is together in the same place, you know exactly what's being deployed. When it's more a federated model, maybe you have a diagram of, oh yeah, these are the ports we want. But that might actually match up to what's actually been deployed, or maybe users via the console have changed things. So this ensures that everything that's being deployed is in one place, and then you can tell from various versions what you have done going forward. And then resiliency. By tying everything together, you can spin up and spin down everything much easier. You're not required on having another team kind of perform a lot of these actions for you. And another really interesting and kind of powerful thing is if something goes wrong, you can actually roll back both the infrastructure and application together to a working version. A lot of the times you'll have a problem either on the application side, the infrastructure side. You don't know which one to roll back, and if you roll back one, it might not fix the problem, so you have to keep kind of taking a long time to get your app back up to a running state where your users can interact with it. And then this last one, self-management. This one's a little bit loosely defined. This is kind of an area me and my team are exploring now. But since everything is written in code and is all in the same place, you can actually have applications manage itself. So this is especially around like the no-ops solution that we want. Since it's in a declarative manner, the application can monitor itself. And if it detects something that is not right, it has the ability to get in the same or the desired state. So this is almost health-healing infrastructure. And then you can add a lot of custom logic to it as well. So potentially, if it's not able to function, it actually can roll back itself, then notify, and do other types of things there. Now, while this is all great, there are some considerations, and there are some other items you'll have to address in order to kind of safely and securely follow this model. And this is specifically around governance and permissions. So by federating out all the infrastructure back to your application teams, you want to have some centralized tools, especially around monitoring, security. You don't want just everyone kind of doing everything. So there are some ways to address this. So this is, for actually my team right now, is another open source project at Capital One called Cloud Custodian, which is a tool that both passively and actively monitors your cloud. It's a rules-based execution engine. So you can define a bunch of rules, and you can have it either passively monitor or actively on API calls, either accept or deny resources. So this will take a centralized team in order to define the standards and rules you want to ensure your environment, especially around public-facing resources. And then around permissions. Since you want developers to own their own infrastructure and the application, they'll need permission to actually create and delete their own infrastructure. However, it's very hard. You don't want developers to be able to, say, terminate other applications. And so you have to kind of manage the way you handle permissions. So generally, it used to be around roles, but now you'll need more of an application-based permission system. And one way to kind of do this is to have a centralized tool that actually has the permissions to do it, and then developers will push whatever changes they want, or have maybe from a pull model from a Git repository. And then in this tool, you'll have to have a lot of your governance checks, and you can run your security rules before actually deploying out to the environment. And here you can actually have a lot of your application-based rules and define really strictly what each application is capable of, ensuring that they each are separately and isolated and not going to be affecting the others. Now these are some like kind of quick little things that my team has noticed when we started to embrace this Judy model in practice. So each developer actually spins up their entire dev environment on their own. So now everyone can work in parallel without ever affecting anyone else. And this ensures that they always have the latest code. Since at the beginning of every day, they'll just spin up the latest environment based off the latest code changes. And all you have to do is change a few environment variables and probably have a smaller and maybe not exactly the same what you're having in prod, but you'll have maybe like smaller version. Another thing we do is we destroy our QA and dev environments during office hours to reduce costs. Since everything is right there in the same place, it's very easy to spin up. And we do persist some things, such as a database that might take a lot of time and waste some developers' time. But the benefit of this is, for example, we actually had a big tutorial with 60 or 70 data scientists that were spinning up large GPU clusters. So we were able to spin up our whole environment right before the session, have data scientists interact with it, spin up a lot of their stuff, do some model trainings, and then we just terminated the whole thing as soon as right after. So we didn't have this expensive infrastructure running for a long period of time. And another really kind of unique and powerful thing we noticed is actually our CI/CD pipelines are now able to both deploy the infrastructure and applications at the same time. So this ensures that we can actually detect problems or potential issues much quicker and address them in the actual real time. So this allows us to be a lot more agile, a lot faster, and make sure our code is much stronger before moving to the dev and then eventually to prod accounts. So yeah, Jitty overall looks to build upon the core fundamentals of infrastructure as code, which include programmability, automation, and reusability, with a little twist of tying infrastructure more closely to your application. So I appreciate you taking the time to learn about a just-in-time infrastructure and kind of rethink the typical relationship between applications and cloud infrastructure. This is really just another way the cloud is changing how we think about and develop applications. And I hope this is really just the beginning of a conversation. And I look forward to your comments and feedbacks, and I'll open it up now for some questions if you want.
So if you have all of your infrastructure code stored with your application code, obviously you have to have something that exists first to run this infrastructure code against. Can you talk about how you determine what needs to exist first? So what's the baseline that exists before you run your infrastructure code?
So you're talking about on the purely infrastructure side or also on the application side?
The infrastructure side.
So on the infrastructure side, you can actually start with nothing. So we actually have examples where you spin up the VPCs, the subnets from the security groups, the IAM roles, all the way up to your application. So we're using our internal framework, which makes this a lot easier. So all the dependencies are built in place. So before spinning up your application, it ensures that everything is there. But it kind of depends on your use case. In practice, you might not want to spin up a database. You might not want to spin up a lot of these things over. So you can kind of abstract it wherever your use case is and how much you want to kind of have your enterprise control versus how much you want to delegate to the teams. So a lot of it depends on your use case. If you're working on proof of concepts, if you're going to be doing more shareable, moving to other accounts, you want to abstract as much as you can because it makes it easier to integrate with other accounts. If you know you're going to be in the same environment, the same thing, then you can maybe abstract just the things that will be changing a lot and that actually have like a direct effect to the application. But yeah, thank you for that.
So how do you find that this scales with like larger teams? So I used to work on a couple projects, and even just if we had to change something with a deployment script or an infrastructure script, like one feature team may not have that new change, and by the time it gets to master and goes out, it can kind of be a mess. So how do you find that it scales to like larger teams with multiple branches going on at once?
Yeah, so I think a lot of that depends on how your team kind of versions and best practices. So we found that having maybe like a develop branch is kind of like the main branch where everything is going to go into. And then the nice thing is being able to spin up everything from scratch and then get in the practice of always kind of redeploying the latest code. You actually make sure you always have the latest. Because we had actually a lot of those problems initially, and that's another kind of benefit we got from this, is we'd always start from scratch, make sure everything is deleted, and then go to the develop branch and grab the latest code. And that's a lot of, especially for big teams, this ensures that you're always working against the latest, because it's always the worst when you make some cool code, you get working, and you realize there's a merge conflict, or actually this won't work with the latest change. So you want to be in the practice of constantly rebuilding your environment with the latest. And you want to make it an easy way so it's not a pain, it's not a big time sink, people are not wasting their time.
You briefly alluded to explorations in NoOps as a consequence of your just-in-time infrastructure design. Can you expand a little bit on what you're exploring and perhaps any reference points that you have for that? Just a curiosity of mine.
Oh, sorry, exploring what?
NoOps.
NoOps?
Yep.
Yeah, so that kind of goes around to the self-healing infrastructure I was referring to. And then a lot of it is tying the kind of CI/CD with the infrastructure and application together. So now we make a PR, the infrastructure will automatically be updated, the application will automatically be updated, and then the ability to automatically roll back. So we actually have on-the-made processes. We have various Lambda functions built into the actual application code that we can update as well. So if there are various health checks that fail, it will automatically roll back and then notify. And then we are not kind of on call. We can, in a typical development cycle, okay, figure out what these problems are, and then kind of deploy again. So kind of making a lot of the monitoring, a lot of the deployment require no operations, and then allowing developers really just to kind of focus on code versus a lot of the integration work and a lot of kind of the manual debugging when things are live. And that's still a thing where that's still early on in our focus there, and that's definitely the path we're trying to get to is how do we minimize as much ops as possible, and how do we get more into just pure kind of automation and that type of stuff. Yeah, thank you. Oh, yeah.
Who maintains the infrastructure as code? Can all the developers do it, or do you have experts on the team that specialize in that?
Yep, so initially a lot of us had various different backgrounds, but we made it a point that everyone start by just deploying the application. And then from there, you learn to debug, you learn to figure out where every kind of piece is. So the nice thing is the framework we built was in Python. So it's not as much a DSL, so it's much easier to read, much easier to kind of figure out how everything is kind of interacting. But it depends kind of what your team's skills are. They don't need to know all the underlying details. I think if you start just with how do you deploy the platform, and then if there's bugs in there, by learning kind of the different bits and pieces, they'll eventually understand more and more of their platform. And as they understand more, I think they'll be better developers. They can think, oh, OK, this might affect this other piece. So I think, but yeah, start by just having them just deploy the code. And in order to get there, you have to make sure it's easy to deploy, and not a whole 10, 15 steps, as easier as possible. And then from there, you can kind of build out everyone's knowledge.